Thank you all for coming. Who am I? My name is Lars Albertsson. I am nowadays an independent consultant. I help people sort of get onto the big data train and get value from the data. I am currently in my career sort of where I started. My first assignment was as a master's student at the Center of Parallel Computing. It was called supercomputing at the time. Today is commodity, and it's called big data. And my career took kind of a turn when a Google recruiter called, and I was able to join Google a little over a decade ago. And at the time, Google was the only company doing what we today call big data. And that was a big revelation to me because it was clear how much value they got out of working with the data and their capacity to work with data. So I've since gravitated towards working with data at scale, and the things in black is where I've had the opportunity. I worked with Spotify's data infrastructure and also what's master metadata at Spotify, which is the data about the artists and the records. I built up a data platform at the Schibsted group. And today I'm helping different companies do the same thing. And my clients range from small startups to banks and old heavy companies. So to give some context, what's this sort of big data train all about? If we look back in time a couple of decades, the first web applications appeared, and they more or less looked like this. You have all of your data in a database, and you have a web service, and then some user interface. And if you want to figure out anything about your customers or whatever you have in there, you just go to that master database. And that has a picture of the current state of things, right? The customer's current address, and your current inventor and so forth. There is little information about what has happened in the past. So that is limiting in terms of analytics. So the next step, logical step, like forward a decade or so, is that the enterprises doing these kinds of things have grown, and there are now multiple applications, and they all have their own little picture of what the customers do and so forth. And the answer has been traditionally to suck out of the data of all of the different databases and put it in a data warehouse. So you get a sort of full picture of what's going on, but you get it also back in time with history because you sort of suck out the current data every day or so. The data warehouses enable you to do analytics and business insights. So that's great. Now, forward another decade or so, and this is a very rough picture of what the architecture in almost all of the data-driven corporations look like today. Instead of the database being at the center with its sort of mutable, changing view of the world, the collection of events is at the center. So you collect every single thing that sort of happens to your company or in your company, or at least every single thing that is generated by humans. So instead of storing the customer's current address, you store that the customer has now changed his address to the new value. And you suck all of this information in and put it in a data lake, which is an ever-growing storage of all the raw events that have happened since the beginning of time. You never change that data. Instead, the data in the data lake is not useful as it is. So instead of mutating it or going directly and doing queries to what's in there, which you would do in a database world, you have refinement steps that take the raw data and transform it and combine it to form features at the right-hand side. These are called data pipelines. And they can either drive the analytics business insights, so the data warehouse ends up being out here, or things that we could not build before, such as machine learning features and data-driven product development, A/B testing, and so forth. So, why do you do this? Well, I mentioned the machine learning features. You couldn't do this before because you didn't have the volume and the detail to do this. But it's not so much about volume and new features. It's actually more about the speed of development, the speed of innovation that you can have, and the speed at which you produce new features to your clients. The ability to be data-driven is really important. It turns out that if you actually measure your innovations and see how well it goes when you come up with something new that you think your customers will like, 10% of the cases you're right, 90% it's either neutral or you're wrong. It's directly harmful. And also the structures of these pipelines enable you to move faster. I'll get to that later. And the data lake is democratized within the company. So if you succeed well in your structure, any team can go to the lake and get the information. And the lake ideally contains sort of the full information that you have in your company. And that increases the speed because you can get features out while involving fewer teams. Now, a number of things can go wrong here. And I'm going to enumerate like 10 things that I see companies stumble with that make the journey through the maze to the gold more difficult. And these are I had a long list and I had to cut it down to like 10. These are the mistakes that I see people make from a like management leader organization perspective primarily. I have a long list of technical mistakes as well. And they are presented in some kind of chronological order. So the first thing that happens, this typically only happens in larger companies, is that there's a mindset that every journey to something new and something big starts with paying a lot of money. And there's a large corporation in Sweden who did a spectacular case of this, where they went to one of the Hadoop vendors and said, so we want a data lake, right? Okay, they bought a big cluster and they poured data in and they didn't know what to do with it. So they brought in consultants from a big consultancy firm. Unfortunately, these consultants hadn't really worked with this before. So yeah. And then they somehow thought that once that was done, they would get gold out of it. And the vendors who sell these things, they actually want you to do exactly this. Because once you pour their data into their platform, they have a very good relation to you from their perspective. They have the incentive to do so. And the warning signs here that you might be falling to this trap is when you hear a lot of talk about the terms data lake or data platform. It's like you will build this up technically from the bottom, and hopefully we'll see value later. Or that you do exactly what the vendor says. You need to own your own journey. And there's a workflow orchestration tool that says up there. I'm going to get to that in a minute, what that is. If you don't know what it is, you probably don't have one, which is a problem. So, second thing that often happens is that you start out with a new interesting tools and sort of embark on this journey. And then people say, we need to scale to very large amounts of data, many terabytes or petabytes, whatever. The thing is, even large companies, if you look at all the original data in a master company, it counts on the order of gigabytes or tens or hundreds of gigabytes, which means that it will fit in a single disk and it will fit in RAM in the largest cloud instances that you can get. At least the human-generated data. Machine-generated data is something different. It's not going to grow faster than Moore's law, so it will forever fit on a single machine, essentially. Which means that you can wait a while before you buy the big Hadoop clusters or spend a lot of money on hardware. There's a lot of talk about big data, but it's not so. The big value is not working at the largest scale in terms of data amount. The larger value is working like smarter with data. It should be called smart data or lean data or something. The value comes from being more efficient. And some of the warning signs here is when you see sort of weird technology coming in. There are lots of startups doing like in-memory analytics databases and so forth. And usually you don't you really don't need much of the funky technology. You need approximately 7 open source tools will make you a great architectural platform. Also, some things common to see is that once you get going, if your developers in their daily work require access to cluster in order to work, if the Hadoop cluster goes down and nobody can work, that's a bad sign. These things do not at all need to be coupled. All right, so you pour some data into the data lake, and then how should you organize? This is a common organization pattern. Like you split it up into teams that each know one thing each, and you sort of pass data between the teams. I worked in a project like this where we had one team that did a collection from the user interface down into the cloud, and then the next team did sort of the pouring from the cloud into data buckets, and then the next team did the cleaning of data, and another team did the user modeling, and then another team eventually did some features. And it took ages to get things to produce value at the end. And very little of what we actually did ended up as end user value. And it becomes very difficult to make new things, right? If some feature team at the end says, oh, we need this, talking to all of these managers and so forth. And one of the signs here that you're going wrong is that it's hard to mention concretely what the use cases actually are, and whether the people that are interested in these use cases are involved in the project or not. Workflow orchestration comes up here again. So what's this workflow orchestration about? The key, the solution to these previous 3 items is to organize your teams around a feature, value that you want out of the data. And that the teams contain cross-functional competence, so that they can, from the raw data in the data lake, produce this value to some end user. And the tool, the technical component that lets you focus on these pipelines producing the value is called the workflow orchestrator. And guess what? If you go to the Hadoop vendors, none of their distributions actually include a workflow orchestrator that's useful. There are 2 of them, good ones out there. One is called Luigi from Spotify, and the other one is called Airflow from Airbnb. So start out small, right? Make a proof of concept that sort of demonstrates some kind of value. You don't need any fancy hardware or anything. Your first data lake could be dumping your databases that you have to a local disk on a big machine, and start from there, work on that single machine, produce end user concepts, and then you sort of scale out from there, and scale out the technology only as you need it, which is usually much later than you think. Okay. So another pattern that happens is that if you work this way, if you're feature-driven, a feature team starts out and they realize, well, the data that we need is not in the lake, it's in this legacy production database, doing something, keeping track of the users or something. So we go talk to that team, and they say, yeah, we're really busy right now. We cannot do that for you, but here we open up access so you can go to our tables and just dump them. And then you realize that internal structure that you're trying to get at is a mess, and it's 10 years of legacy, and it's hard to realize what's what, and there's backwards compatibility and so forth. So what happens is that these teams end up using a lot of time in our cleaning and understanding the source data. So if you want this to work out, you need commitment from teams owning interesting data in your organization to push that and export it in a sensible format out into your lake. Okay, so we get going. you spit out some features, you have one feature team, and they decide to do things one way. You get the next feature team, they have liberty to do whatever they want, so they do things another way, and so forth. And eventually you end up with a really heterogeneous systems. This is typically what happens to startups that sort of scale out a lot. I think the extreme example is Uber, where I think they have like 20 Git repositories per engineer in the company. So they all contain different types of technology and so forth. And this works fine for a while. You deliver results. There's nothing to block the feature teams from working well. But eventually, this like grinds more and more to a halt. And some things are really difficult to do in such an environment. For example, it being GDPR compliant and working with privacy is difficult. And also, if you want to do wide changes, if you want to change the business model of how you store users and so forth. And this. The risk here is if you have a culture of autonomous teams that can do whatever they want, then you will likely end up here. If you have no technical governance structure that steers you toward a fewer number of components and so forth. I was at one company where we had this culture, and there were about 25 different ways to store a date, 25 different formats to store a date. That's like freedom of choice that adds negative value. And some of them were really insane. I'll take this out of order, actually. So I mentioned that you pour everything you know into the data lake. You never change it, and that's the raw data. And then you move from there. One of the features here is that if you follow these principles, you have immutable data, you are able to reproduce and recreate your executions and so forth, then you can afford to do errors. You can afford both humans to do errors by writing software bugs, and you can afford machines to have errors because you can redo things. It is the undo operation of data architecture, which means you can move fast. If you compare to user interfaces, let's say you have a user interface and you want to change something really important. Back in the dark ages, these user interfaces would say, "I'm about to change something really important. Are you sure? Okay, cancel." And then another sign, "Are you really sure? Okay, cancel." And in this such an interface, you pay every time you do something. You pay, and also you get sloppy. So these don't really work. Modern user interfaces say, "I have now done this thing, click here to undo," which means that you only pay if you make a mistake. And this is a way to working with data where you have undo operations, which means that you can move much faster. But in order to do so, you really need to make sure that you have the raw data that hasn't changed, so you can go back in time and redo your operations. And if you process your data as it arrives, for example, I was in one project where they decided that all of the events, we had the IP address, so let's tack on the geolocation by doing a geo-IP lookup. That would be valuable. That was great until the geo-IP lookup went down and we lost a bunch of data, right? So don't drop your data. And don't store it in a mutable way. If you have legacy mutable databases where you change data, dump them on a regular basis. Dump them every day. In data mature companies, it's common to have thousands of copies of the user database, for example, just to be safe on the safe side and be able to reverse operations. So going back a step, this is the reverse of the random walk where you just walk about really fast and end up with a heterogeneous mess. This is when you you're over ambitious with the governance, which means that you apply the procedures you usually have, the rituals and so forth. This is something that rarely happens in startups, but often in enterprise environments. And because of the ability to undo things, which I just mentioned, many of these rituals are not necessary. They are these, OK cancel windows that pop up everywhere. Pushing things to staging environments for before going out to production, doing acceptance testing, doing performance testing. All of these, in most cases, can be discarded. Because you're not, if you're working with these data pipelines, you're not working with the online systems. If you goof up, the users never see it. You have time to go and undo and repair. And in many cases, for example, somebody suggested to me recently that we do performance testing of Hadoop. Right? That's meaningless. We have a small Hadoop cluster. We know that they scale to tens of thousands of nodes. We're not going to get run out of power. Somebody else has already done that for us. That doesn't add value. So if you have this kind of culture, try to isolate your teams that work in this way and say you have free limits. Do work however you feel works well for you in order to start and get going. You can govern the unimportant things, how you store dates, for example, but not skip all of the rituals that you have. And then later, if you experience pain, yes, then you can add process. So during summer, a Fortune 2000 company called me. This is a big international, non-Swedish company. The head of strategy decided to give me a call. And he basically wanted to know what can you do with AI. There's this new thing coming. I realize it's going to disrupt us and affect our activity. I need to know more about it. Which is a perfectly reasonable question to say, perfectly reasonable to collect that information. The odd thing was that 3 weeks before, the CEO of the same company had gone out publicly and said, "We are from now on an AI-first company." Okay. And this somehow ended up on the head of strategy's table. So that's not meaningful. If you're not mature in working with data, you cannot make a jump in this hierarchy. So you can sort of climb, but that's a slow process. But the good thing is that down here in the sort of basics of working with data, collecting the data, instrumenting your applications so that they emit the data that you need, getting the pipeline structure in place and so forth. That's where the most value is. And this is also the easiest things to do. So this is the low-hanging fruit. The things up there that are buzzwords in the media, those things are really hard to do. And they are not as likely to provide end value for you. You can make proof of concepts, of course. You can do an AI chatbot or whatever to show that you have an ambition in the area, but don't expect it to generate a lot of business value until you've sort of gathered the value from the lower steps. So as you grow, something that I see happening here, and I missed the most important sign, is like drowning in operations. When this grows, more and more time is spent operating these systems, like doing more and more of these undos because things go wrong and so forth. And the reason is not that it's difficult. This is actually, these environments are really convenient to work with as an engineer. The reason is that there are cultural reasons. One of them being that somehow people think that this is a data project. The standard best practices of software engineering, we don't need to do them here. We don't need to have integration tests and code reviews and continuous integration and so forth. And unless you control that path, you will end up with way too much technical debt, and you will be really slow. This takes a while before this happens. There are two things that you can do. The simplest one is to just add regular backend software engineers that have a sense of quality here to the teams. And the other one is that there are a number of tools out there that will steer you away from best practices, that will make it difficult to test things and so forth. Usually these cheapest tools, the open source tools, are really good at making things testable, with some exceptions, whereas the commercial tools are more difficult. There are some exceptions there. For example, tools such as Apache NiFi, which is like a graphical tool that will enable you to get fast and going quickly with things, but it will be very hard to manage a larger installation using that tool. So speaking of software engineers, this getting value out of data, in particular with machine learning, is really a team sport. There are like 3 pillars here. The first one is the data scientist. Data scientists, they take data and produce models out of it. Models that do recommendations or classifications or ad targeting, whatever. In order to do meaningful work, a data scientist needs to partner up with data engineers. These are the ones that know how to collect the data and get it in, right, to work with, and also to take models and put them into production so that they produce value on a day-to-day basis. And if you have only these 2, you will produce something that is very technically very interesting, but will not make end users happy. So the third part here is the product owner, business developer, product manager, whatever you want to call it, that knows what the others are doing, but connects this to business value, and cuts out the parts that don't generate value and so forth. And anytime you have an imbalance here, you will make a far from the perfect product. And it's important that all of these people involved here really have a mutual respect for each other, because they all have a lot to learn from the other parts. So if you get, for example, some of us the original back-end engineers are a bit arrogant with respect to how things work and so forth. And people really have to have an open-minded attitude. And the bonus mistake number 11 is not to do it at all. Right? Don't worry, you will get things wrong. Everybody gets things wrong. That's fine. But you cannot afford to not have a relation to this, right? The sort of big data / AI hype is one of these technical revolutions, just like electricity and computers and internet and so forth. If you decide to stand on the side, then you might very well not be out of business, like Kodak did in for example, in one famous decision that they decided that the digital cameras was not their thing. And that's a very big company that just doesn't exist anymore. And since one of the main benefits is the iteration speed, the product development speed, players that are data-driven come in and disrupt old areas. The best examples are Airbnb and Uber. They're, old, mature business areas. In Stockholm here, we have Spotify, we have Klarna, where you think there would be no possibility to like come in and take a significant market share, but just by being data-driven, they sort of outpace the competition. That's it. Questions? I think we have a few minutes.